Hey everybody, thank you for joining us here. My name is Raya Solomon. We're gonna not really wait, we're gonna jump in pretty quickly here. This is recorded, so if you miss any part of it or if you want to share any part of it, you'll be able to do that immediately after we end the webinar today. So I'm Raya Solomon, I am the Marketing Director here at IronCore Labs. A little bit about us. IronCore is a data control and privacy platform, and we're based in Boulder, Colorado. So while we wait for more people to jump on here, I am making a poll live at the bottom. So if you click in, you'll be able to vote on which search service do you use. You should be able to see results once you voted. Awesome. So that poll will be live throughout the webinar. Feel free to fill it out. We will probably mention it at the end. And speaking of which, there is also an ask a question button at the bottom here. At the end of the webinar, Patrick is going to do a Q&A, and we'll go through a lot of questions. So feel free at any point to submit your question, and we will mark that and answer it at the end. All right, well, Patrick, take it away.
Thanks, Raya. So I'm Patrick Walsh, and in brief, my background involves a lot of security software and threat research, combined with a fair bit of enterprise cloud application development, and IronCore is really the confluence of all of those things. All right, so enough about me. Let's get going. So we live in the information age, or so they tell me, but what good is that if you can't find information, right? Not very good. I mean, how do we resolve arguments before we could search Google at a moment's notice and then, pounce with, see, I told you a peanut isn't a nut, it's a legume, and a beefalo is too a real animal, it's a cow-bison hybrid. So search services like Google work on the same principle as the index at the back of a book. For anyone who still remembers paper books with indices, you look up a word alphabetically and it gives you a list of page numbers where the word occurs. Except instead of page numbers, we get back URLs or document IDs these days. But where modern search is way more useful than a book index is when it comes to cross-referencing results and then ranking them. So I can do a search for legume on DuckDuckGo and get back the definition, the nutritional facts and the recipes and stuff. But I can also search for legume peanut and get a list of the most popular pages that talk about both peanuts and legumes at the same time, which is a better search choice if I want to win my argument. So while internet search engines are where we most interact with search, most applications have their own search capabilities built in. So your mail app, your CRM, your password manager, I hope you use one of those. And for operational things too, we capture tons of logs and activities and stuff from all over the place. We might barely look at them, but if we're doing it right, we're at least indexing them so we can find things later if we need to. Now, if you're a software developer and you need to add search to your application, you have a few choices. If your search needs are simple, as when you need just a filter to return all results based on a single word or an exact phrase, you might be able to use standard databases and their filtering capabilities. But if you have a lot of searchable data, or you care about ranking, relevancy, or searching for multiple words that might be in different places in the text, then SQL queries are likely too limited and too slow, and it's time to graduate to a search service, if you haven't already. So if you're looking at search services that you can run to back your application, today the most popular search software by far is called Lucene. It's an open source search engine that's written in Java, and it's used pretty much everywhere. Lucene by itself only handles the search bits, so running a search service comes with a lot of other concerns like authentication and authorization and redundancy and scalability and usability. And these things are provided by layers that sit on top of Lucene. There are 3 projects that together own the lion's share of the market doing this. There's Elasticsearch, OpenSearch, and Solr. Of these, I sometimes refer to Elasticsearch and OpenSearch as non-identical twins, since they were the same thing until earlier this year. So if you missed the fireworks, here's the gist. Elastic is the Dutch company that created and primarily maintained the Elasticsearch open source project, but they recently changed the license on Elasticsearch to make it hard for cloud companies like Amazon to resell without paying them. The code's still public, but the change added some strings to it. So in response to that, this summer, Amazon took the last fully free version of Elastic's open code and started a new open source project with that called OpenSearch. So this new project retains the original license, but its future roadmap and improvements will come from the OpenSearch community and from Amazon. So for the moment, these two things are largely identical, and they'll always be somewhat tied together since they both are based on Lucene, but over time, they'll evolve in different directions probably. Now let's talk about Elasticsearch and OpenSearch security for a minute. They have three main security features. First, they have facilities for authentication and access control. Some of these are pretty advanced and include things like role-based access controls on a document or field level, but those capabilities mostly only come into play when users like employees have direct access to the search service and are directly interacting with it. More commonly, a web application sits between the user and the search service, and you log into the web application, but not the search service directly. And then you just have one set of credentials. The application has its credentials for talking to the search service, and that's it. And then that application has access to search everything and is responsible for managing and filtering results and making sure the right users see the right data. The second part of the security story is audit trails, showing logs of queries and who made them. But again, in the typical web application context, the search service sees every request as coming from the application, which is a single user, as far as the search service is concerned. So the audit trails lack crucial details like the source of the requester's name or IP address. This could potentially be recovered by cross-referencing with other logs if you really needed to, but it'd be kind of difficult. And the third part of the security story that's built in is around data protection, sort of. Today, these tools support encryption at the disk level on a per cluster basis, but this encryption has no bearing on who can access the data, and in fact doesn't stop anyone from accessing data in normal scenarios when the server is running. Let me explain. So the encryption offered in Elasticsearch and OpenSearch is this low-level encryption. You send the data to the data store, and as it saves it to disk, it gets encrypted along the way. This is what is used by 95% of the world today in server-side computing. And it's better than nothing. Really, it's important actually. But anyone with access to a machine that holds sensitive data will be able to see all that data. It's transparent to attackers as well as to the entire operating system and to users of it. The only thing that transparent disk encryption really protects against is theft of data when someone steals a hard disk or when a drive goes bad and gets thrown away, which is important. So if you want to protect data on a running server, then you probably want to use application layer encryption, or ALE, which just means you encrypt the data before sending it to the data store. Lots of variations on how that works, but that is the essence of it. So Elasticsearch and OpenSearch built-in data protection? Not really. There's no meaningful data protection story while the cluster is running, and that's a pretty big mess. Certainly not in a web application scenario. And that's where Cloak Search comes in. Here at IronCore, we're making it easy to bring application layer encryption to your Elasticsearch and OpenSearch clusters, including the ones that are part of managed services like those from Elastic and AWS. So today, your application talks directly to the search cluster. I'm presuming a web application context here. Cloak Search drops in as a transparent proxy that sits between your application and your search cluster. Everything on this side, on the left side of the proxy, is normal, meaning it's plain text and unencrypted. But over here, between the proxy and the search service, it's a different story. Everything on the right side is encrypted, and the search cluster is blind to the protected information it holds, and it's blind to what's being searched on. So the problem with encrypting data before you send it to a data store, to a database or other data store, is that the database no longer knows anything about the data it holds. It's a bunch of random bytes as far as the database can tell. This is a good thing because it means hackers and overly curious or even malicious administrators can't see the data. But at the same time, it makes it difficult for your application or legitimate users to find the data they need since they can't ask the database to filter on it. A typical SQL query for searching for a person named Jarvis might look like this. And in a database that uses only disk level encryption, we will get a result. But in that same database, when we encrypt the data before storing it, our query returns an empty set. And of course, you could still fetch the data, decrypt it, and perform any number of analytical queries on it from there. You could also fetch specific rows by ID and decrypt them on demand, just get that information as a carry along. But you inherently lose the ability to use database functions to filter on the data. And that's one of the major reasons why we built Cloak Search. We want to help people to protect their data thoroughly. We want to help them to adopt application layer encryption, but we want to help them to be able to use that data after they've protected it. And with cloaked search, we search on top of that encrypted data, which means we don't have to decrypt anything in order to get results. But we do need the proper key in order to conduct a search. And when results are returned, we use appropriate keys to decrypt the results before passing them back to the caller. This is sometimes called data in use encryption or partially homomorphic encryption. Now, other than best practices, what does encrypting the data at a higher level get you? And if the proxy is essentially transparent, then does it really bring better protection? In short, yes, but also, it depends. Let's take a look at some real world issues we've seen recently in the news. So according to the Ponemon Institute, cloud misconfigurations are tied for the #1 cause of data breaches. That's a stunning statistic and hard to understand until you witness the sheer complexity of most infrastructures today. With complexity comes mistakes that are hard to spot, and they could strike at any time with any change that brings unintended consequences. So for example, the VPN provider QuickFox recently misconfigured their Elasticsearch instance so that it was publicly available on the internet. Researchers found 100 gigabytes of data involving 500 million records and 300,000 customers. A similar misconfiguration exposed the records of around 2 million people, including passport details, who are on the secret terror watch list. And in case you think this is a problem that pertains only to unsophisticated companies, Microsoft last year had the same thing happen to them. An internal customer support database in the form of 5 Elasticsearch clusters were accidentally made accessible to the outside world, compromising the data belonging to 250 million customers. Their security response team said this: misconfigurations are unfortunately a common error across the industry. We have solutions to help prevent this kind of mistake, but unfortunately, they were not enabled for this database, which is, of course, another misconfiguration, which is sort of funny, but not. All right, so those were issues with Elasticsearch clusters being directly addressable from the internet without proper authentication and permission settings. But more commonly, though, an application intermediates and passes searches along to a back-end search cluster after validating and sometimes augmenting the user's input. But there's a class of attacks known as injection attacks that trick systems into running commands or queries controlled by the user. Search backends are also susceptible to these. These attacks get much less attention than SQL injections, and they're less likely to be caught by web application firewalls and other security tools. But they can be just as devastating. So in this example, the user's search is crafted to evade the role-based access control result limits. In other words, the application adds some logic to filter the results to only return things for a particular role, and with a specially crafted query, it gets around that limitation. So as another example, Salt Security released research showing widespread misconfigurations, really more design mistakes in Elastic stacks that passed user input through to backend search clusters and allowed users to search indices that they should not have access to. So in particular, they found that the multi-search capabilities of Elastic were underprotected and can be abused to query any index in the same cluster and not just the index intended by the vulnerable application. They found this everywhere. In each of these instances that we're talking about, cloaked search would have prevented access and exfiltration of data for all protected fields. So that is, if the OpenSearch or Elasticsearch index is accidentally published to the world, then the data produced by it will be meaningless to anyone querying unless they also have the proper keys. And in the multi-search example, cloaked search would not operate on that query, it would pass it through, and at worst, the protected fields would just be passed back in encrypted form. But even more likely, in many cases, if it looks like there's multiple tenants being queried, cloaked search would catch that, block the entire request as not having a clear data segment specified. We'll explain that more in a minute. So how do you get started with cloaked search? It's pretty easy. You can run things locally with a single command to try it out, or you can spin up our Docker container in your infrastructure. Across all our products, IronCore never sees sensitive data or private keys, ever. When you spin it up, you have to configure a few things, starting with which indices and fields you want to protect. We recommend you pick one field to start with and then expand from there. Generally, you'll protect just text fields that might have sensitive data and leave numeric fields and date fields and things alone to preserve ordering capabilities. Next, you'll configure your data segments, which for SaaS companies means tenant mappings. A tenant is a customer. Lastly, you'll determine what capabilities you need on each field. Then you'll index some documents and test your code by pointing it to the proxy instead of the search cluster. So for example, I have a JSON document here with a title and a body, and you might decide to encrypt the title, the body, and the author, but to leave the other fields as they are. Then you might configure the title to support substring searches, so you can search for partial words like quart star to match against quarterly. And you might add the phrase search capabilities for the body field, so you can search for things like sales expense and get back just documents that have those two words next to each other in that order. And finally, you might enable fuzzy match, which is phonetic matching against the author field, so that it doesn't matter if you spell Catherine with a K or a C, and whether it ends in an INE or a YN. But note that these capabilities have to be turned on before you index the documents. So you have to pick up front what you're going to be doing for queries. As for supported queries, we currently work only with query string fields, and some of the capabilities have to be specifically configured before their work. But we support most standard qualifiers like should, must, and should not. We support Booleans like and or. We support parenthetical subqueries. We support field prioritization to make sure that matches in a title, for example, count as more important from a ranking standpoint than matches in a body field. And we support prefix and suffix wildcard matches. We don't support non-text fields unless you're okay treating those fields like their text. We don't support regular expressions or wildcards in the middle of words. You can't run aggregations across protected fields, can't use range queries, can't use synonym expansion, and you can't search across multiple tenants at once. But that last one is very intentional. It's a security feature that contains the blast radius of common coding mistakes and injection attacks when passing user input through to a search service. So in a situation where you mix data from multiple segments into one index, you must specify the tenant ID as part of the query, such that there is unambiguously only one. You can also have just one data segment per index if you want. We'll take a query, and provided the authentication is correct, there's one and only one possible data segment, and we have access to the needed keys, then we can transform the query into one that uses equivalent key tokens. The details of what's being searched are obscured from the search service. The raw fields are also fully encrypted before being stored with the search service. So Cloak Search can be run completely standalone with no external dependencies, but for multi-tenant SaaS apps, you can choose to integrate Cloak Search with SaaS Shield. So this handles the orchestration of multiple keys and multiple logging syncs for audit trails for different tenants or customers. Customers have the option of holding their own keys in their own KMS without sharing private key material. If they desire a feature that is often called BYOK or CMK, that gives them all that control over their data. And if you're a SaaS provider, you can almost certainly charge extra for this. Most folks who offer it in the industry today do. So the deployment ends up looking something like this. Cloak Search sits where it normally would, but it talks to the SaaS Shield stack for key management purposes before it can query or index documents. And then the SaaS Shield product manages leased keys, refreshing leases, and talking to the vendor's key management server. It'll also call out to appropriate KMSs, key management servers, and log syncs belonging to customers as needed and depending on per tenant configurations. So everything up here in yellow is your network and your infrastructure, but your customers can hold their keys in their own infrastructure outside of your network, wherever that may be, and it could be even a different cloud provider. We have a feature called leased keys that makes this resilient to network connectivity issues while helping them to control and monitor their data still. Okay, we're in the home stretch here. So here at IronCore, we're pretty mission driven. We recognize that there's only so much we can do individually to protect our own data when so much of it actually resides with third parties. Whether those third parties are our service providers like our banks and our health insurers and so forth, or they're the online software we use every day. We want to make it just much harder for these trusted service providers to lose the data of their customers, of us. And we want to empower people and businesses to own and control their own data. In many cases, this can be a massive competitive advantage for companies that embrace the approach. It makes us incredibly sad when we hear that applications and companies were hacked and the sensitive data they held wasn't encrypted. The average web application has 0 layers between it and its data stores, which means it's just one bug away from all that data getting owned. And this is true regardless of the data store, but it's doubly true for search clusters, which otherwise don't offer reasonable ways to secure the data. Application layer encryption, when it's done right and with smart key management, adds a layer between the application and the data store. It can isolate tenant data, and it can still allow for that data to be searched and used. Someone who compromises the network or who otherwise gains access directly to the data store does not come away with the protected data. They have more work to do and significant barriers to face before they get the crown jewels. And this is how applications should be built. For more information, we have lots of details in our docs on how it works under the hood. We have a live demo playground on our website. We have a 5-minute self-trial that you can do on your own laptop using Docker, or you can reach out and let's talk. And now I'd be happy to answer any questions you may have.
All right, so we do have a few questions. Just a reminder, if you have any questions, there's an Ask a Question button at the bottom where you can submit them for Patrick. You can also share your question in chat if you prefer to do it that way. And if you want to share this recording, again, this will be available as soon as we're done here. So that will be available to everybody. All right, question number 1. Can you use custom tokenizers? And this is from Joe Green.
So a tokenizer is a way of taking like a document or a text field full of words and turning it into its individual components. We don't currently support custom tokenizers. We use some pretty standard ways. We do give you some ability to control what's tokenized and how, for example, with stop words and things like that, though. We're looking at that in the future. We'd like to understand people's use cases. So if you have a use case for a custom tokenizer, please let us know why and what it is you need there.
Awesome. Let's see. How do you configure keys for different data segments? This is also from Joe.
So you integrate with SAAS Shield, and SAAS Shield is what manages all of that. SAAS Shield is pretty cool because it end-to-end encrypts all of the key details and key connection details. So a tenant can store that in such a way that the vendor can't ever view it. The management then is done through a UI or through an API, but it allows the tenant to directly take control of their own keys. Or if you're a vendor, you're a SaaS application vendor, you can set up defaults, you can configure keys, and you can configure those either by UI or coming soon API.
And then talking of indexing, is there ever a scenario where you will have to re-index? This is from Wendy.
Yeah, so when you first turn on Cloak Search, and if you already have a search service full of data, you will have to pull those out and update them, but going through the proxy in order to get them encrypted in the first place. That's the main thing. If for some reason you wanted to turn off encryption, you might do it then. Importantly, in terms of updates, like for example, if you're updating your service with AWS, all of that will happen just as normal. It doesn't even need our proxy involved at all. So the sort of the reindex updating kind of workflows will continue to work just as always.
Okay, and that ties in, I think, a little bit. We have another question of what if you have a lot of existing documents? So the actual setting up process, what does that look like?
Yeah, so there is that one-time cost. Anytime you enable a new protected field, you will have to reindex those so that they get encrypted properly. And the cost of that is really dependent on how many things you have, how many documents you've indexed. You can do it on a per tenant basis, though.
All right, and 2 more questions here. I think, see, this one is, does it work with managed services like AWS?
So yes, absolutely, it does work with AWS. We have some more features and functionality in the pipeline as well to make some of that even smoother. But it is built to work with, so Elastic has a hosted managed service for Elasticsearch. Amazon has their Amazon OpenSearch service, and we are compatible with both of those. Or if you run your own stack, that'll work just fine too.
And then last question, unless anyone else wants to submit anything that came to mind, how does it work for upgrades?
So I kind of touched on this before, but there is a caveat here. So I should explain that in a Elastic or OpenSearch index, you have the option of storing the source with the data or not. If you do store the search with the source with the data, then you can do the upgrades without having to do anything special. It's all self-contained. Amazon OpenSearch, for example, forces that functionality to be turned on specifically for the upgrade purpose. If you don't store the sources with the data, then you would have to sort of re-index it, pull it out of its primary location, let's say a SQL database, and then re-index it in order to do the upgrade usually. Now that's a requirement. It sort of depends on the update. If it's a minor version update, you're probably not doing that. That's usually for major versions that require fresh indexing. Whether or not it requires fresh indexing in that case on upgrade is really dependent on OpenSearch and Elasticsearch and has little to do with us. The main thing is if your source is stored there, you won't have to go through the proxy to do the process, to do anything.
Awesome. Well, thank you for answering those, and thank you guys for submitting them. Looks like that is the last question. So once again, feel free to share this webinar recording. We'll be sending out an email to all everyone who signed up and sharing some of our resources, the interactive demo here. We have all the doc site, all the product pages, everything. And if you have any questions, feel free to reach out to us. We would love to set up a call with Patrick, with our team, and help you figure out if this is the right. Thank you, Patrick,
Thanks,
for
everyone.
presenting.
Thanks.